Alright, so any point on a perpendicular segment bisector will be equidistant from the endpoints of the segment that it bisects. So let's, I don't know, what does all that mean, right? Um, so two lines or line segments or rays or whatever are perpendicular if they form a 90-degree angle, like this. Um, a segment bisector is something that splits the segment into two equal halves. So if CD, if that line segment is bisecting AB, then AC and CB have the same length. They're equal halves of AB. All right. So according to this theorem, a point on CD, like for example D, or we could just draw some other, I don't know, any point. Oops. Any point will be equidistant from the endpoints of the segment that the the line it's on is, or the line segment it's on is bisecting. Uh, so the distance from to D, for example, would be the same as the distance from D to B, is all that's saying. So you can use this fact to solve for missing information. It's like a game. Um, so here's kind of a silly one, and then we'll do a little bit more of a serious one. Okay, so DC bisects AB. Okay, which is what we were talking about. So that's good. Good to know. Now we can use this fact to our advantage. So AC is 3. The measurement of this line segment AC is 3. Okay. CD is 4. And we want to know DB. So what we're going for is this distance here. I'm just going to draw it like a dotted line or something. Okay. So, what we can do is we could get this distance first, and then it'll be the same as that distance. So if you focus on this distance, I mean, this is a kind of silly way to do this, which we'll see in a second, but if we get this distance, okay, so yeah, so this forms a right triangle, you can see, with sides 3, 4, and whatever. So we could use the Pythagorean theorem, 3 squared, 3 squared plus 4 squared equals this length, AD. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So 25 is c squared. So c is 5. 5 times 5 is 25. So this is 5. And since so therefore by this theorem, this length is also 5. Now the reason why this is silly is we could also just say if this segment is has a length of 3, then this segment also has a length of 3, because this DC is bisecting it, splitting it into equal halves. So this segment has to have the same length as this segment, right? So we could do a 3, 4, 5 triangle like that. Anyway, so that's a little practice to show what we're actually talking about here. And now let's go into an example that's a little bit more realistic, like something that you might confront in your own math career. Let me take a sip of water though first. All right, thanks. I feel better. Okay, so EF, I should indicate that these are line segments. EF bisects GP. So this line segment EF bisects GP, and we know that this is saying that there's a 90-degree angle, so it's a perpendicular bisector. So I'll say EF. I'll also add this information that EF is perpendicular to GP. So this theorem will apply. Okay, so EG, let's draw some stuff. EG is, I don't know why I like to do dotted lines. I guess it's because the line isn't really there. Of course it is, but I want to pretend like it's not. I don't know. It's just a thing. So EG is 2x. Let's make this solid again. And then let's switch. Okay, so 2x is what that's saying. EG is 2x. EP is 30. Is 30. FP is x over 2. FP is x over 2. Let's find FP. Okay, so FP is x over 2, so we need to figure out what x is before we do anything. Alright, well, by this theorem, any point on a perpendicular segment bisector will be equidistant from the endpoints of the segment. You should say that to your friends really fast a bunch of times in a row. They'll be impressed. By that, we know that 2x is equal to 30. Okay, these are the endpoints of this segment. Segment GP has the endpoints G and P. EF is the perpendicular bisector. So any point on EF, including E itself, will be equally distant from G as P. So if the distance from E to G is 2x, then the distance of EP, which is 30, is equal to that. So I could say 2x equals 30 by this theorem. Then we divide by 2. So x is 15. The question isn't what is x, the question is what is FP, and FP is x over 2. So FP is 15 divided by 2, which is 7.5.